guys, welcome back. So let's start working on our example for how to calculate the mean using data set from our textbook. So the data set that I chose is airport data speeds. And you can find it in Appendix B in the back of your textbook. And it's really the measures of data speeds of smartphones from 4 different carriers. So what we're going to do is we're going to use the first column, which is the data values for Verizon. And we're going to calculate the mean. So I want to go ahead and put it on our slide. So give me just a moment to set it up so that we can calculate the mean. All right, so we're going to find our sample mean formula, which is x bar equals the sum of all the x values divided by lowercase n. Now, what we're going to do is we're going to take the 5 data values that we found in that list or that we were given in the previous slide. We're going to add them together in the numerator, and we're going to divide by the total number of data values we were given. And we were given a total of 5. So I'm going to add the data values together. I'm going to divide by 5, and it's going to give me 30.74 megabytes per second. So the average data speed or airport data speeds for Verizon is 30.74 megabytes per second. Now we're going to move to something called the median. And the median of a data set is the measure of the center that is the middle value. And so it's the middle value when we place the data set in an arranged order. That means I'm going to put it either in ascending order or descending order. So in order to find the median, you always want to put the data values in order. It doesn't matter if it's decreasing or increasing, just put them in order. All right, so there's some important properties about the mean as well. I'm sorry, about the median as well, excuse me. The median does not change by large amounts when I include outliers. So we consider the median to be a resistant measure of center. The great thing about the median is that it doesn't use every data value in the data set. So if I add in a larger value, it doesn't really change the median. If I add in a smaller value, it really doesn't change it, okay? So in order for us to calculate the median, we first have to sort the data values, and we have to sort them either in ascending or descending order. Now, dependent on the number of data values, if they're odd, there's a specific formula, and if it's even, there's a specific formula. So if the number of data values is odd, then the median is the number located exactly in the middle of the list. If the number of data values is even, then that means we have to find the 2 middle numbers and take the average or take the mean. So let's go back to our 5 Verizon data values that we were given in our mean problem earlier. And so let's go ahead and work that out and see what we come up with. So the first thing we're going to do is to sort the data values, and I sorted them in an ascending list, meaning I'm starting with the smallest number, moving to the largest number. And because there are 5 data values, we know that the median is going to be the number directly in the middle. So our median data value here is 23.1. Now let's look at the median if we were to have an even number of data values. So we're going to repeat the first example, but we're going to include a 6 data speed, which is 24.5 megabytes per second. And then we're going to find the median. So we're going to set the problem up just the same. However, you'll notice if I try to get to the middle of my data value, I have 2 directly in the middle. So what I have to do is take the average of the 2 middle data values. So 23.1 and 24.5. Well, when I take that average or I take the mean of those values, you'll get 23.80. All right, are there any questions, comments, or concerns for me? Well, guys, I look forward to seeing you back in our next video. And our topic for our next video will be the mode.